Hi, I'm Matt, and in this video we're going to go over how to calculate the average or weighted atomic mass of an element. Before we go into calculating average atomic mass, first we need to talk about what exactly atomic mass is. So atomic mass is the mass of a particular atom of an element, and it's measured in AMU, or atomic mass units. The mass of a proton is 1.007 AMU, the mass of a neutron is 1.009 AMU, and the mass of an electron is 0.0005 AMU. But using these decimals gets tedious, especially when there's a lot of protons and neutrons. So what we do to simplify our calculations is we approximate the mass of a proton and the mass of a neutron as both being 1, and then the mass of an electron as being negligible, so we approximate it as 0. Therefore, to determine the atomic mass of a singular atom, we could just sum up the number of protons and neutrons in the atom's nucleus. This leads us to isotopes, which are atoms of the same element, meaning they have the same number of protons, but a different atomic mass due to a difference in neutrons. A good example of this is carbon-12 and carbon-13. They're both carbon, meaning they both have 6 protons, but carbon-12 has 6 neutrons, and carbon-13 has 7 neutrons, which causes their different masses. So now, using what we said on the last slide, let's try to solve some problems. So, we're told that an isotope of chlorine has 18 neutrons. What is its atomic mass? Based on the formula on the last slide, we're going to say that the atomic mass is equal to the number of protons plus the number of neutrons. To get the number of protons, we're going to have to look on the periodic table. Chlorine's atomic number is 17, meaning it has 17 protons. Therefore, to get the atomic mass, we're just going to have to add the 17 AMU from the protons plus 18 AMU for all the neutrons to get that the atomic mass of this isotope of chlorine is 35 atomic mass units. For the second question, we're told that an abundant isotope of bromine is bromine 81. How many neutrons does it have? So first, just like the last question, we're going to figure out how many protons bromine has using the periodic table. So since bromine is atomic number 35, it has 35 protons, which weigh 35 atomic mass units. Therefore, filling in the formula, we get that 81 equals 35 plus the number of neutrons. Subtracting 35 from both sides gives us that bromine 81 consists of 46 neutrons. So now, this may lead you to the question of if a proton and a neutron are said to have a mass of 1, how the periodic table has decimals, sometimes of like 0.5. So that's because the masses given on the periodic table are generally not the mass of one isotope, but instead the average of all the isotopes of an element, weighted based on how abundant in nature each isotope is. The weighted average is referred to as the average atomic mass, where we say that the average atomic mass is equal to the abundance of some isotope multiplied by the mass of that isotope, and then we're going to sum up for all other isotopes. One quick note about this formula is that the percent must be converted to a decimal when we put it into the formula. So for example, if an isotope had a percent abundance of 50%, we wouldn't put 50 into the formula, but instead would put 0.5. We're going to do some practice with this formula on the coming slides. So for our first question, we're given 2 isotopes of hydrogen and their abundances, and have to calculate the average atomic mass. So we're going to use the formula from the previous slide that says that the average atomic mass is equal to the abundance of each isotope multiplied by that isotope's mass. So in this case, that's the abundance of hydrogen 1 times the mass of hydrogen 1 plus the abundance of hydrogen 2 multiplied by the mass of hydrogen 2. We know that hydrogen 1 has a mass of 1, and then we multiply that by 0.9998, which is 99.98% converted to a decimal. And then for the second half, the abundance of hydrogen 2 as a decimal is 0.0002, and since it's hydrogen 2, we know that the mass is 2 atomic mass units. Plugging this into a calculator, we get that the average atomic mass of hydrogen is 1.0038 atomic mass units. It's important to note that this doesn't match the 1.008 shown on the periodic table. This doesn't mean our answer is wrong, it's just slightly off due to the approximation that the mass of a proton and a neutron is 1 instead of the decimal equivalents that come after it. For our next question, we're going to do the same thing, but this time we're going to be looking at a different element, vanadium. So the formula is the same. We're going to multiply the abundance of each isotope by its mass. So here, the average atomic mass is equal to the abundance of vanadium-50 multiplied by the mass of vanadium-50, plus the abundance of vanadium-51 multiplied by the mass of vanadium-51. In this case, that gives us 0.00250, which is 0.25% converted to a decimal, multiplied by 50 AMU, and then for vanadium-51, the abundance would be 0.99750, and then the mass would be 51 atomic mass units. Multiplying these each part together and then summing them up gives us that the average atomic mass is 50.9975 atomic mass units. And once again, this deviates slightly from the periodic table, but this is still the correct answer. For our last example, we're going to try a slightly harder one. Here we're going to determine the weighted atomic mass of strontium. But unlike the past two examples, here we have 4 isotopes we have to take into account. But nonetheless, the formula is the same. It's the abundance of each isotope multiplied by the mass of each isotope. So in this case, the average or weighted atomic mass is equal to the abundance of strontium-84 times the mass of strontium-84 plus the abundance of strontium-86 times the mass of strontium-86 plus the abundance of strontium-87 multiplied by the mass of strontium-87, finally plus the abundance of strontium-88 multiplied by the mass of strontium-88. Plugging into this formula, we get 0.0056 for the strontium multiplied by 84 atomic mass units, plus 0.0986 times 86 atomic mass units, plus 0.07 times 87 atomic mass units, plus 0.8258 multiplied by 88 atomic mass units. Doing the math here gives us that the average atomic mass of strontium is 87.7104 atomic mass units, which, while it does deviate slightly from that of the periodic table, it is still very close. One thing you'll notice through the past 3 examples is that even though we're getting a decimal instead of a whole number, the average atomic mass, the value for it, is usually very close to the most abundant isotope. So here, strontium-88 is the most abundant of the 4 isotopes. So if we were to round our average atomic mass to the nearest whole number, we would get that's very close to 88, which is the most abundant isotope. While that's not always the case, in this case it was, and in many cases it will be. Now that we've gone through some questions together, here are 4 practice questions for you to test your understanding. The first one asks you how many neutrons there are in the nucleus of a zirconium-94 atom. And then questions 2, 3, and 4 ask you about the weighted or average atomic mass of different elements using the tables provided. At this time, I encourage you to pause the video as the answers will be provided for you on the next slide. So the answer to question 1 was 54 neutrons. Since there's 40 protons in zirconium, we subtract 40 from 94, which yields an answer of 54. Then, using the formula for question 2, we get that the weighted atomic mass of boron is 10.801 atomic mass units. For question 3, we get that the weighted atomic mass of chlorine is 35.484 atomic mass units. And lastly, we get that the average atomic mass of neon is 20.1877. Hopefully you got these. If you have any questions, feel free to leave them in the comments below and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.